Well, good morning everybody. I got a lot on at the moment. I'm just doing the final touches to Mario's knife. Hola Mario! Mario has been watching all my videos and he emails me and comments on all my videos. It's a funny one, this, because Mario's Spanish and our whole conversation has been conducted thanks to Google Translate. So anyway, it's good. I feel as though I almost know Mario, and yet I've never spoken a word of his language. Isn't it amazing, really? Anyway, Mario, I'm going to finish your knife now, and you'll see it shortly. It's oak with black liners. This is Mario's knife. Just before I finish the handles, look, so I'll show you the knife. You can't really, not much to see at the moment, but I've got to turn that into a thing of beauty. Right, let's get to work. Next time you'll see it, it'll be a thing of beauty. Right guys, what you're looking at is a major shop update here. I've managed to control the speed of the linisher now, which was always set to fairly high speed, but now I've managed to control it by the addition of 4-step pulleys, one on the motor drive shaft, one on the machine drive shaft, 2, 3, 4 and 5-inch pulleys and reversed. Currently we're on a step down. We're stepping the speed down, so we've got a 2-inch pulley going to a 5-inch pulley, which has given me a speed step down of 2.5. so for every 2.5 rotations of the motor, the back pulley spins at 1 revolution. This motor spins at 1500 RPM, which means that the back drive shaft will spin at 600 RPM. It takes that drive through 2 bearings at the back, and it goes to this back pulley here, which is 4 inches in diameter. A bit of simple maths, 4 times pi tells me that the circumference of that wheel is 12.5 inches, which means that it will pass 12.5 inches of belt across the face of the platen here. So we've worked out we've got 600 RPM on that back drive shaft now, so multiply 600 into that. That means we're going to get 7,538 inches of belt across the platen in a minute. Divide that by 12, that'll give me feet. 628 feet a minute. Divide that by 60, that'll give me seconds. And that means I've got almost 10.5 feet of belt a second coming across the platen now, which is excellent. It's nice and slow and steady, and I'll let you see it running at that nice slow steady pace. And that's just fantastic. You can see it there. Belt changes are simple, quick, efficient and effective. I can select any speed I want in between. So simple. Why didn't I do this years ago? Well, months anyway. Now I've gone through all the different ratios now, and I'm on to the high speed now. Now I'll work out for you the speed of that. We've got a step up going on now. We've gone from a 5-inch to a 2-inch, which means that this is now spinning 2.5 times faster than the motor. So the motor spins at 1500. The back pulley will be spinning at 3,750 revolutions per minute, which means this is also spinning at 3,750 feet revolutions per minute. We know it's passing 12.5 inches per revolution of belt, so multiply that by 12.5. That means I've got I can't read the figures on my calculator, I'm missing a digit on the calculator is gone, but anyway it's about 46,000 inches per minute going over that platen. 12 divide that by 60, 65 feet per second now passing over the platen, and this is what that looks like. It'll sound different and it'll spin a lot quicker. And that's take off a lot more steel. Right, that is an absolute fantastic update for me. Something else I've got to show you. Don't know if you can see that. Yeah, they are. I don't know if you're. The most peculiar belts I've ever seen. Trizax belts. They're not cheap either. There's about £70 worth of Trizax in there. So knives are going to be finished on Trizax from now on, which is going to improve the finish of the knives. If I spin you round through 180 degrees, what we've got going on here, turn the radio down, this is the press bench if you like. This little press here is specifically for lever work and for pop studs, press studs. It means that everything's done in a vertical. And you get much more accurate seating of the press studs and rivets, etc. for lever work, or for kydex or anything for that matter. Next to it is a little half-ton arbor press covered in dust now. The only function that I use this for is for my lever stamp. When I want to make my logo into the lever, I put the lever in under there. I've got a logo stamp and force it down. That's just a small half-ton press. I have heard some people refer to it as a big press, but no, it's only a small half-ton press. It's quite a heavy little thing though. And then coming over here is my Norton number 2. This is 2-ton fly press. Extremely heavy compared to the other press. It took all my strength to actually manhandle this machine. It's got a huge cannonball, and that is really some weight. You wouldn't want to drop that on your foot. And here down beside it, I don't know if you can quite see that, is a nice anvil which Brummy John gave me. The main purpose of this press is going to be for stamping the logo. I've got a stamp being made which will fit under there, and then the press will ensure that the logo stamp comes down again, straight down, not at any funny angle, so it'll give the most accurate and crisp impression of the logo into the steel. Other tasks can be for bending and straightening and controlled manners. Steel, if I've got anything which is slightly bent or I want to tweak something, I can do it with the Norton number 2. They don't make fly presses like this anymore. This probably dates from the 1950s. But extremely solid press. As I say, it probably weighs close on my body weight. You can see also I had to mount it on an extremely thick table, and then down beneath that I had to build a concrete block bench for it, because the inertia involved is quite immense really, and it was obvious that my other workbenches weren't going to take that sort of hammering. Hi guys, I'm out in the garden, school kicking out time. Getting a lot of road noise. It's a busy road, just a few yards that way in front. Right, this is where I'm at. Simon's knife. This is Mario knife, and this is IK0YGJ Carlo's knife. These sheaths are not finished yet. I'll finish them later on this evening. Let's make sure these shot. Simon, I know you asked me to leave the ends square. I forgot to do it with this knife. I rounded them off. I was in my old normal modus operandi, and rounded them off. So that's the Corian white handled knife with mosaic pins, black fibre liners, 01 tool steel, 58 RC. Leather sheath, no fire steel loop, a dangler. This is the Burl walnut. It's turned out very nice. White liners. Quite difficult to keep the white liners clean even with brand new abrasive belts. They would pick up the colour of the belt. I got them reasonable in the end. Mosaic pins again. Fits the hand lovely. Nice even grinds. All the knives. So those are your two knives, Simon. Mario, hola chicos. No, this is Carlo's knife. The sheath needs finishing. I've just been wet forming it. The knife needs polishing, not finished yet. Not long to finish it though. Carlo sent me this wood. Boozy wood is it? Very thin scales for Carlo's dainty hands. Carlo's a Morse operator, like me, and he has fairly small hands, I think. That's your knife, Carlo. Super grinds again. Just got to finish off. I won't put it in there, it's a bit damp. Chief's still a bit damp. Just got to finish off your dangler. Fire steel has been finished already. That's Carlo's knife. Mario. Hola, Mario. Mario speaks to me in Spanish and I have to use a Google Translator. Sheath needs finishing, not long now to finish. No fire steel loop, but a dangler, left hand. On the plastic. Oak scales. Black liners. So that is your knife, Mario. There you go. Hope that's okay. So that's all for now, folks. And remember, stay sharp.